Hello everyone, welcome back to my channel. In this video today we will learn about a typical application release process. So let's start. The first step would be writing and building the code. In the process of developing an application, the first step for a developer would be to write the code using any text editors like Visual Studio Code or PyChar. The code is initially run on the local machines of the developers, that is on the local host 8080. To make this code accessible to users, it must be hosted on the server. The developer's local machine on which the code has been written is the development environment, and the server on which the application will be hosted is the production environment. The second point is setting up the server. To move the application from a local environment to a production environment, we need to set up a server. This server could be a physical server, a virtual machine in a data center, or a cloud-based instance. In order to run this application on the server must be configured with the necessary runtimes like Java, Python, etc. according to the programming language that was used in the development of the application. If the application uses any library or packages, then the exact version of the library and the package has to be configured in the server. The third step is deployment. After configuring the server, the application code has to be transferred to the server. Now this cannot be done by simply copying the code. The code has to be converted into an executable format. This process of converting a text code to a binary file is known as building the process. Tools like Maven or Gradle are used in this process. The fourth step is version control with Git. Let's say the application is already moved to production and it's being used by the users, but there is a need to add a new feature to the application. Since multiple developers would be working on the same code base for a new feature, to manage the code changes and facilitate collaboration among multiple developers, version control systems like Git are used. Git acts like a central repository. It allows developers to work on the same code base simultaneously without overwriting each other's work. This central hub helps manage projects, track issues, and streamline collaboration. Every coder has to install and configure Git on their machines. Pull the code from the central hub using git pull command, do the changes, and then push the command to the central hub using git push command. The fifth point would be automating with CI/CD. Copying the code to different environments manually can be tedious and conflicting. To avoid this manual work, we use CI/CD pipeline. CI/CD tools like Jenkins, GitHub Actions, or GitLab CI/CD helps us to automate these manual tasks and create a pipeline. With one of these tools configured, every time the code is pushed to the central repository, it automatically gets pushed to the build server, and after building the executable, it is automatically moved to the test server and tested. Upon successful test, it is automatically moved to the production server and deployed. Now this allows the code changes, new features, and bug fixes to move faster through the pipeline and to be deployed often with lesser amount of time and lesser manual effect. The sixth point would be containerization. For the applications to run successfully on the servers, dependencies and libraries used in the code needs to be configured on the servers. This needs to be manually installed and configured on all the servers where this code runs. If we miss configuring even one of these packages with the right version in the right way, it will lead to errors and unexpected outcomes. This is where containers come into picture. Containers package the application along with all its dependencies into one image that can directly be run on any systems without worrying about the dependencies. Docker helps in working with containers. The developer creates a Docker file which specifies the dependencies, and that Docker file can be used during the build process to build an image. The major functionality of a container is that it enables isolation between processes, so each container is an isolated instance, and hence this allows us to run multiple containers, each having its own separate instance of the application on the same server. The next point would be orchestrating containers. Let's say initially we had only one server, but with the increase in users, we add more servers and run our application on all of them. Since we have containers, we just need to run the containers on them. But we need the containers to spun up when the users increase and destroyed when the users are less. We need to ensure that if a container fails, it is automatically brought back up and that's when container orchestration platform comes in. Kubernetes is a popular container orchestration platform that helps declare how containers are to be deployed and ensures that it is always run the same way as declared. It helps auto-scale containers as well as the underlying infrastructure based on need and manage resources on the underlying service to ensure optimal resource utilization. It also ensures that if a container fails, it is automatically restarted. Next point would be infrastructure as code. Now, every time a new server is to be provisioned, it needs to be set up in the exact same way as others in the cluster. It needs to have the right resources assigned to it, the right version of operating systems, same kernel settings and other softwares that needs to be pre-configured on it, such as the Docker runtime or Kubernetes packages, and all of these needs to have the exact same configuration. So doing this manually can lead to human errors in misconfiguring infrastructure, resulting in having to rebuild the entire server. To automate the provisioning of the servers, tools like Terraform can be used. Terraform automates the provisioning and configuration of servers irrespective of what cloud platforms they are on. It also ensures that the servers configured are always in the same state. If someone manually changes the configuration on these servers and not through Terraform, it changes back to make sure that the states defined is preserved. The state is defined by configuring a Terraform manifest file. This process of stating all the configurations in the form of a code is known as infrastructure as a code. All of the infrastructure configuration information is now stored in the form of a code and is stored in the source code repositories. This can be considered as any other code that can be tracked. Now, once the servers are provisioned, the configuration of these servers can be automated by tools like Ansible. While Terraform is more like an infrastructure provisioning tool, Ansible is an automation tool that helps to configure these infrastructure once provisioned. There are many areas where Terraform and Ansible overlap, but each has its own benefits in different areas. While Terraform is used mostly for provisioning and deprovisioning infrastructure, Ansible is used for post-configuration activities such as installing the software and configuring them on those servers. So similar to Terraform, Ansible uses code to configure servers. This code is called Ansible playbooks, and this code also goes to the source code repository on GitHub. The next point would be monitoring and maintenance. Once the application is live, monitoring its performance is crucial. Servers have to be maintained. We have to monitor these servers and take preventive measures when required. We have to monitor the CPU utilization and the memory consumption on these servers. Monitor the processes, identify what process is causing higher consumption. For these monitoring processes, we use tools like Prometheus. Prometheus collects information or metrics from different servers and stores it centrally. It also visualizes them graphically using tools like Grafana. Grafana helps make sense out of the data collected by Prometheus by visualizing it into charts and graphs. The DevOps pipeline integrates various tools and practices to automate and streamline the process of building, deploying, and maintaining applications. By leveraging version control, CI/CD pipelines, containerization, orchestration, and infrastructure automation, organizations can ensure a more efficient and reliable application release process. Monitoring tools then provide ongoing insights into application performance, allowing for more continuous improvement. Understanding and implementing these DevOps practices can significantly enhance productivity, reduce errors, and accelerate the delivery of high-quality software. As you navigate through each stage of the pipeline, remember that each tool and practice plays a critical role in achieving a seamless and effective DevOps workflow. So, in a nutshell, code is pushed to Git, Jenkins builds and packages it into a Docker image, Kubernetes deploys and manages the application across servers, and Prometheus collects metrics while Grafana visualizes the data for insights.